Okay, I welcome all of you to FUTO UNVEIL. My name is Franklyn Einstein, as usual. I don't have any interesting intro to give you guys, but whatever. So today we're going to discuss about the electric field. We're going to solve problems that covers the whole topics of electric field. There's no even need for you to go and study the whole of the textbook and whatever. This question alone covers everything you need to know about electric field. You understand? So right now, the first thing we'll do now is to go into the equations you need to solve electric field. You get? We want to solve several questions that covers everything about electric field. You get? So when you solve this question, when you learn them, the best advice I will give you is to go and find more questions on it and use the question given to you and solve more questions. There's no need of you stressing yourself. Alright, so I said, welcome to FUTO UNVEIL. My name is Franklyn Einstein. So now let's go into the equation you need for electric field. Now I have some few equations here I'm going to write for you now. Please learn them. Get your jotter, get your notes, get your pen, and start jotting. Very important. And start early. That is the best thing. And then for the questions, I'm going to teach you how to answer question in your test. Right? Your test have a pattern as a question. For physics test, all right, have a pattern. You do this step by step process. You understand? So we're going to start with the equations. Now the first equation I'll write is the electric field itself. All right. So now the electric field itself is given by this. Electric field E is equal to force over charge. Yes, electric field E is equal to what? Force over charge. The force exerted by a charge, or the force that a charge is being experiencing, all right, when it comes in an electric field. So electric field is equal to force over charge. So now what will be the unit now? Force is in Newton, charge is in Coulomb. So therefore the unit of electric field is Newton per Coulomb. Now there's another equation which most students don't even know about. Very important equation. That equation that for electric field is equal to voltage over distance. Very important. Voltage over distance. All right. I think we apply this equation more when we enter into capacitors. All right. Yeah. Where you have to apply. Yeah, you have to find the potential difference and the voltage. You get that? So unit for voltage is volt, and unit for distance is what? Meters. Alright, so let's go into the second equation. Now for the second equation, the second equation relates electric field with mass, with acceleration, and with charge. And it's very simple. In the electric field, E is equals to mass times acceleration over charge. Obviously, if you look at it very well, this equation and this equation are not far-fetched. Force is equals to mass times acceleration from Newton's second law of motion. Alright. So whenever they ask you that a particle, especially if the particle is being specified, there are two specified particles in electric field. Two of them, the electron and the proton. And when you see these two particles in the question, the two characteristics or the two features of this particle that you must know because they may not even tell you their values, that you must know is their mass and their charge. We're going to solve question on that. I'm going to tell you the mass of an electron and a proton and the charge of an electron and a proton. So this is the equation that relates electric field with mass, with acceleration, with charge. Find the acceleration of a particle and electric field. Make use of this. Alright? So that's that for that. Now, the electric field that is being emitted by a charge Q. And when it's being emitted, electric field covers a particular distance or a radius. Is given by electric field is equals to K Q over R squared. K is called the constant of proportionality. It has a value. K is equals to 9 times 10 to the power 9 Newton meter squared per Coulomb squared. This is the value of K. Alright, while Q here is the charge itself. You understand? So Q here, the charge itself, is emitting an electric field. Now R now is the radius of the electric field is being emitting or the distance. Alright, so that is very simple. So now the next thing enter is in the vectorial part of the electric field. The vectorial part. The vectorial part is very simple. the vectorial path is being applied in this scenario. For example, a charge is emitting an electric field, and there's a particular point P in either the x-axis or the y-axis or the xy plane. Alright, these are the three scenarios or the three type of questions that you see that you to apply the vectorial path. Alright, so a point P is on the x-axis and a charge Q is there emitting an electric field. Alright, what will the electric field felt by point P? The answer is this: electric field E is equals to electric field emitted by that charge Q multiplied by, now this is the vectorial path now, the position vector of where P is, which is the filling particle, right, minus the position vector of where charge Q is, right, all divided by the resultant distance between them. You understand? So this is the electric field that is emitted by the particle, by the charge, right, which is on this, and multiplied by this is the point or where that point P is on the x-axis or on the y-axis or maybe on the xy plane, any of them, minus this is the position of where the charge is on the x-axis or the y-axis or the xy plane, all divided by the resultant distance. Remember, if it's on the xy plane and the charge is on a different axis and the point P is on a different axis, let's say the charge Q is on the y-axis while the point P is on the x-axis or vice versa, the resultant distance will make use of Pythagoras theorem, alright, to get a resultant distance because they are on two different axes. Alright, if they are on the same axis, maybe because the x-axis or the y-axis, we don't make use of Pythagoras theorem. We just calculate distance between where the point Q is and the point P is on that axis. Alright, understood. Now there's another equation known as the dipole moment. Now the dipole moment, we use P for dipole moment. Now the dipole moment P is equals to twice the distance and the charge, or most textbook write Q. This is dipole moment, twice the distance of separation of two charges. Now they'll give you two charges in a question, where pick just one charge, right? Because those two charges are equal in magnitude. Alright, so you just pick only one charge, then they'll give you the distance of separation. You now multiply that distance of separation by 2. Remember to convert everything to standard units. Alright, so this is how it's being written. Now there's something we call the torque. Alright, something called the torque. Now the torque use tau for torque is equals to the dipole moment times the electric field sine theta. This is torque. Alright, the torque experienced by an atom, by a molecule, is equals to the dipole moment times the electric field sine theta. Now there's another one which is very, very common. It's called the maximum torque. Now the maximum torque, okay, which is tau max, and the maximum torque is when sine theta is equals to 1, that is equals to PE. So sine theta is equals to 1, right? So 1 times PE is just PE, the dipole moment times what? Electric field. And that is very, very simple. Alright, so now let's go on into knowing the electric field of a dipole moment. Electric field of a what? A dipole moment. Electric field of a dipole moment is electric field E is equals to the constant proportionality times the dipole moment itself divided by the cube of distance. Alright, this is the electric field on a dipole moment. So these are the equations that we need to solve any question on electric field. Hope you guys understand. Hope you understand. Very important. Now the electric field on a dipole moment is the constant of proportionality times the electric dipole moment divided by the distance cube, right? Cube, not squared. Distance cube. So please don't forget, just this in your notes and try to memorize it. Physics is very, very simple. I'll coach you guys on how to succeed in physics, especially here in FUTO. All right, very, very important. Now let's go into solving questions. Let's see how we can apply these equations to questions. So like this problem solving, right? So now let's move on to question 1. The question 1 says, what force will an electric field of 4.6 times 10 raised by 7 Newton per coulomb exert on a charge of magnitude Q equals 20 microcoulomb? This is a question. This could be your test question. How do you solve this kind of question? It's very simple. All right. Now the first step, let's write the solution. All right. Solution. All right. The first thing to do, especially in your test, is to write down the parameters given to you. All right. Now, what force? You're asked to find force. All right. So force is what you're asked to find. All right. Will an electric field of 4.6 times 10 raised by 7 Newton per coulomb, without them even telling that this electric field, you should know that electric field is in Newton per coulomb. So this is electric field. Electric field is 4.6 times 10 raised by 7 Newton per coulomb. Exert on a charge of magnitude Q equals 20 microcoulomb. So magnitude Q is equals to 20 microcoulomb. You might say a question that is very, very simple and just jump into the question, rush the question, and you make a lot of mistake. After writing your parameters, you check these parameters, are they in the right SI unit, right? Because if you solve with a wrong SI unit, you have failed the test. You have failed the test, right? So you check. Force, you're asking for force, all right? Electric field, Newton per coulomb. Obviously, that is the unit of electric field, Newton per coulomb. Charge, 20 microcoulomb. No, charge is in coulomb, not microcoulomb, right? So we need to convert this microcoulomb into coulomb. And how do you do that? Now, this is actually equals to 20. Micro means times 10 raised by negative 6 coulomb. Perfect. Now then you find an equation that is very close to finding the quantities that relate to the other quantities in the equations all together. So I want to find an equation that relates force with electric field with charge. And the equation is the formula for electric field itself. Electric field is equals to force over charge. Right? Now we are asked to find the force. Next step is to make the quantity we are asked to find the subject formula. How do we do that? Now we cross multiply, right? When we cross multiply, we find that force is equals to charge times the electric field. Impute your values. What our charge? 20 times 10 raised to the power negative 6. Alright, now what electric field? Times electric field is what? 4.6 times 10 raised to the power 7. Right? Now when you multiply that, you get 920. 920 Newton. And that is the answer for this question. It's as easy as that. You have to answer the question in your test. The parameters, right? SI units, the question, impute your parameters, and you punch your calculator and you get your final answer. It's as easy as that. I hope you guys understand. In case you have any questions on electric field, you can drop it in the comment section. Alright, I'm going to answer every question that you drop there. Alright, so now let's move on into the question 2. Now, in question 2 says, what is the magnitude of the electric field intensity at a point in an electric field such that an electron placed there experiences an electric force equal to its weight? In a question given to you, electric field intensity and electric field are the same thing. Jot that down. Right now, this looks strange. There's no value there, right? We'll have to solve it. But it's simple. Now, solution. Obviously, in electric field, a particle must be there, alright? A particle that emits charge be there. And that particle is an electron. And whenever the particle is being specified, you must know two things, the mass and charge. And the two particles that are being specified on the electric field, the electron and the proton. Okay? Now for an electron, let's write down the mass and the charge of the electron. Now the mass of the electron is 9.11 times 10 raised to negative 31 kilogram, and the charge of the electron, charge QE, is equal to negative 1.6 times 10 raised to minus 19 coulomb. Now the negative I wrote here doesn't really mean anything. What it just tells you that okay, an electron is more negatively charged than any particle in the atom. Alright, so the negative is not needed in the question. Alright, you get that. We've written that. We've written what you know about the particle. Now let's read the question again. What is the magnitude of electric field intensity? That is E. Right. At a point in the electric field, so that an electron placed there experiences an electric force equal to its weight. The electric force, let's call it F, is equal to its weight. Its weight. The force is equal to its weight. What is the weight? Now remember that weight is equal to what? Mass times acceleration due to gravity. The mass of the electron times what? Acceleration due to what? Gravity. Now in your test, they majorly use 9.8 meter per second square, but for the sake of this question, to make things more simplified, I'm making use of 10 meter per second squared. Understood? Alright, so now what the mass of the electron? That is 9.11 times 10 to the power negative 31 times 10, and that will be 9.11 times 10 to the power negative 30 Newton. Alright, and let's find the electric field. The electric field is equal to force over charge, right? The force is equal to the weight. This is the weight, and the force is equal to this weight. So this will be our force. 9.11 times 10 to the power negative 30, or divided by our charge, 1.6 times 10 to the power negative 19. And when you divide that, you'll be having 5.6 now, if I'm not mistaken, times 10 to the power negative 11 Newton per coulomb. That's how to solve the question. You're done with the question. It's very, very simple. So whenever a particle is being specified, an electron or a proton, you should know their mass and their charge, and you impute the one that you needed. Here we need mass and we need charge. In a question where we don't need mass, we can usually charge or anyhow, but we can't. It's not possible for us to use only mass in a question that is in charge. Right? You must make use of mass and charge or only charge. Alright, so that is the answer for this question. This is very, very simple. Alright, so in case if you want private tutorials, you can call me. My number will be placed here on the screen. Alright, so this is all for this question. So let's move on to the question 3. Question 3 says that what is the electric field at the surface of a proton of radius 10 to the power of negative 15 meter? Okay. Solution. What's the electric field at the surface of a proton of radius 10 to the power negative 15 meter? That's all. But let's solve. It's very simple. Now, what's the electric field? So, electric field, what I'm finding, alright? At the surface of a proton, a specified particle. What about a proton? A proton, very simple. I know that the mass of the proton is 1.67 times 10 to the power negative 27 kilogram. Let's know that. The charge of a proton is positive 1.6 times 10 to the power negative 19 coulomb. For the positive, to show you that the proton is more positively charged than any other particle in the atom. So this is just 1.6 times 10 to the power negative 19 coulomb. Alright, radius R is equal to 10 to the power of negative 15 meter. What equation relates the electric field with the radius and with charge or mass? For mass, don't really see anyone. Alright? But remember that this is a particle emitting an electric field. And the formula for that is electric field is equals to K Q over R squared. What's K? 9 times 10 raised to the power 9. What is my charge? 1.6 times 10 raised to the power negative 19. All divided by, now 10 to the power 15. You can write that down on the calculator like that, or you can express it as 1 times 10 to the power of negative 15 meter. They're the same thing. Alright, let's write 1 times 10 to the power of negative 15 all squared. Alright, make use of brackets, they're very important. Alright, look at this very well. So if you punch that, what are you going to have? 1.44 times 10 to the power negative 9. Am I right? All divided by 1 times 10 to the power of negative 30. And if you divide that, you have 1.44 times 10 to the power 21 newton per coulomb. Right? Do you get this question? Very simple. We just saw that there's a specified particle, a proton, yeah? Right? I know the mass and charge of a proton. Very important. It is very important. But do not forget that one to read early. Right? Now I have tips of studying physics. If I hear in FUTO and passing, it's very simple. Because you hear a lot of complaint that physics test went badly, physics this one did this one, blah 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 blah. You don't need those excuses. Right? I'm teaching you guys how to be passing the exam in the next video. Alright? So now we're going to stop here for now. I have more questions which is in other videos, so go ahead, click it, watch it, like it, subscribe for it. Alright, so put everything in their right answer units. They are very, very important. Alright, so please like that thing, like, press like. Now press subscribe, press it. You press subscribe, press like, share to your friends, share to your department. Let them learn all these things. If you want classes, if you want tutorial classes, call me. I'm there for you. I still remain Franklyn Einstein. I'll tell you bye for now.